Welcome back to Database Fundamentals. This is Module 2 of Database Fundamentals, and it is about relational concepts. In this module, we're going to talk about referential integrity and normalization, which is another big topic.
One, definitely.
That's right. And I think we're going to get into a couple of other small topics around constraints.
I think we should. We're probably going to introduce constraints at this point, so we have an idea as to how they'll help with the referential integrity piece of it.
But this is Module 2 of a 5-module course. If you've skipped Module 1, we talked about some of the core concepts about databases, and we'll be going on into other fireworks demos later on about how you create objects in your database and how you get information in and out of your database, and then a little bit about administration of your database. But now we're going to get into some of the relational concepts. So not quite data modeling yet, but we're going to talk about sort of the concepts that are the fundamental pieces you'd need to know before you can actually go and create a database.
Well, you brought up a good point in the previous session where we talked about the idea of data modeling. So this really focuses on that aspect of data modeling in the sense that, okay, I've got my ginormous Excel spreadsheet. You guys have got me convinced I want to move it into Access or SQL Server. How do I go about doing that? Well, how do I decide what do I take into consideration when I'm actually going to design that model that I'm going to use inside a SQL Server or Access? So what we're going to talk about here is what's called normalization, and we're going to look at what referential integrity and constraints, pretty much what we've already discussed here. So the idea of normalization is really it helps us decide how we're going to build our tables out for our content. What this does for us is it allows us to use a strategy that's been designed to determine what content is going to be stored where. So normalization is the process of organizing that data in a database within tables and establishing relationships between those tables. We hinted to that in the previous session. The process is used to also help eliminate redundant data. So if we go back to our DVDs, we had talked about that we have hundreds of DVDs, and if we have a genre of jazz, I might have that title in there 50 times, 500 times. It depends how many DVDs I have that are jazz related. So the idea of that is just kind of a little bit overwhelming. So if you look at a spreadsheet that's got thousands of rows and 30, 40, 50 columns across, if you look at it, you're going to look and see a lot of redundancy. And one of the things that helps with normalization, or normalization helps with, I should say, is the fact that we can eliminate that redundancy. By default, there's 5 normalization forms, as you can see here. One is eliminating repeating groups, all right? Eliminating redundant data is number 2. And the third level is eliminate columns that are not dependent on the key. We'll introduce what that means in just a little bit. 4 and 5 are isolated independent multiple relationships and semantically related multiple relationships. We're not going to drill into those at all. I just want to show you out there, if you look up normalization, you're going to see 5 levels. Most databases are designed to 3, and that's what we're going to focus on here.
So in the first module we talked about, we're not going to talk about data modeling. And now you're showing me that there are 5 normal forms of normalization, and we're going to talk about just the first couple of them. So this is another, this is a huge school of thought around what normalization means, and you go really, really academic, but we're going to keep it simple and talk about those first couple.
Yes.
But it's another opportunity for further study.
Yeah, this could be hours and another whole entire class.
I bet you could talk about normalization for like 3 days.
Exactly. All right, so first normalization. How do we work with our content? The first normal form means the data is in an entity format, which means all of these conditions have been met. We've eliminated any repeating groups. And by the way, we have an example of this. So you're going to see this with okay, it looks good in print and text, but what does this mean? Well, we're going to demonstrate this for you. Create a separate table for each set of related data. Boy, we talked about that with our CDs, how we're going to create a table that are, instead of having them stored in Excel, we're going to create a table for, for our artists and maybe for the genres and for the different types of tables. And then we need to kind of tie those together, and we're going to identify each set of data within the table. We're going to tie that using what's called a primary key, and we're going to introduce that as well. We're not going to use multiple fields in a single table to store similar data. That's pretty much what a spreadsheet does for us. We don't want to do that. We want to avoid that. So we're going to set up this relationships between the tables to allow us to create that. And we do this with, this is just introducing the first normal form. Our second normal form ensures each attribute or each column describes the entity. So again, if we go back to our CD is going to be, we're going to have a row for CDs. We want to make sure that every entity or every column in there is directly associated with that CD. So it's going to, and we're going to actually tie these tables together. We're going to be able to reference one table or CD table to our genera table by using what's called a foreign key. And again, I promise you we'll show you what that means here. Records should not depend on anything other than the primary key that's in that row or that table. And again, we'll expand on that. And we can create what are called composite keys. Composite keys, in order to make something unique, I may have to use multiple columns. So we could, and we'll explain that as well. So we could create what's called composite keys to make sure that we have the uniqueness in those rows. Third normal form checks for what are called transitive dependencies. They eliminate fields that do not depend on that key. So I might have extraneous information in there that's not relevant, and I want to put that in a separate table. So I may do that, and as part of the third normalization of the third normal form, when I'm massaging that data to make sure it's all in that third normal form, we're going to make sure there's no columns in there that aren't directly related to that CD. All right, and again, we'll show you that here. In general, if the contents of a group of fields apply to more than a single record, those require a separate table. So again, just conceptually, all right, Brian, you've got me convinced that we want to take our CDs and we want to put them take them out of a spreadsheet, put them in a database. How do I do that? So we're going to look at how we're going to address that using this third normal form. As I said, there's a couple other ones. There's a fourth normal form called, BCNF, so I don't have to try to pronounce the names. We're not even going to worry about those. There's a slight risk of not having the perfect design, but it shouldn't affect the functionality if we don't implement fourth and fifth normal forms. And that's why we're not even going to address those at this point here. All right, let's take out this table here. This table here is kind of like a spreadsheet at this point, but we've got unnormalized table. We've got a table here that has student number, to be more precise, advisor, the advisor's room number, where we can find that individual. And then for student 1022, they have a class 101-07, class number 2 is 143-01, 159-02. This is an unnormalized table at this point. So what we're going to do is over the next few slides, we're going to take that content and we're going to normalize that content. We're going to implement first normal form first, then second, and then third, and you'll see what we have for a result of that. Well, if you remember correctly, the first normal form, as it says here, is no repeating groups should be in that table. So notice what we've done here. We've taken class 1, 2, and 3, which is a repeating entity, and our group, and what we've done is that now we're going to have student. So now we have student 3 times. We have student 1022 with the same advisor, with the same advisor room, and the same class number. So you can see we got rid of the repeating groups, but now we've got some redundancy. We're going to address that in the next normal form, in the second normal form. So we've taken our unnormalized data and we've added some additional rows to it, and we've consolidated the number of columns that are in this table. All right, so we've taken that content and we now have no repeating groups because we've applied the first normal form process. Now, as we move into the second normal form, we're going to eliminate redundant data. So now what we've introduced, we've taken that one table and we've created 2 tables. The table now is called students. So for student 1022, his advisor or her advisor is Jones, and that advisor can be found in room 412. Student 4123 has a different advisor. She can be found in room 216. So that's a separate table. Now if we go to registrations, because we can't just drop the information about the registrations, we created a second table for the student number. Student number 1022 is going to be attending class 101-07, as well as 143-01, as well as 159-02. That's a pretty light load, don't you think? Only 3 classes? Come on, dude, don't be a slacker here. Anyway, and then student number 4123 also taking 3 classes. So we've taken the content, we've split them out now after first normal form. We've introduced a second table that's going to allow us to avoid or eliminate that redundant data. Let's take it to our next level, our third normal form. Eliminate data not dependent on the key. Let me go back just 1 second here. We're going to see here that in the student, we have 1022, we have with the class number, but we have multiple rows, and you can see the students, that was under registration, excuse me. The students, we have student advisor and advisor's room. So if we go to our third normal form, we've got faculty, we've got student number 1022, their advisor is Jones. Now remember, if I go back, I'm going to flip back one more time. When I look at this, I've got student number, I've got Jones, and I've got the advisor's room was 412. Well, the main item, or the main column in here is student number. That advisor room is not directly associated with the student number, so it does not belong there if we're going to normalize our content. Hence, what we do here is we introduce a third table. Now we're going to have a student, my rows are off a little bit, we're going to have our student, which is 10022, their advisor is Jones. Now I want to figure out where's Jones, where the room number is for Jones. I'm going to jump over to the table called faculty, and that faculty table is going to have the room number, and also we're going to include some additional information about Mr. Jones, and that's the department number that they belong to. All right, so again, no redundancy, and every table or every row in both these tables so far are directly associated with student number. So we've got student number, the direct association advisor. The advisor, the direct association is the room number and the department number. Now we go to our registrations table and we have student number 1022. That's going to be attending class 101-07. 1022 will also be attending 143-01, and as you can see, it rolls down that way. So we've applied the third normal form by looking at these, because now we have our student number as one table, and it's mapping to the faculty table using this advisor name, and it's also mapping to a student table using the student name. So we've taken this spreadsheet, or this unnormalized table, and then we've created 3 different tables out, and we've applied the third normal form. First normal form, second normal form, and third normal form to get that to what's called third normal form in the normalization process.
You may have just blown my mind a little bit. Can we go back
Oh,
a couple
absolutely.
of slides and look at the original?
Right back here. So here's our
That's
original.
right.
Yeah.
So I just want to just talk through that one more time.
Okay.
We've got student information, we've got the advisor information, we've got the advisor's room, and we've got the schedule for each student in one table. That's the unnormalized table on this slide.
Yes.
And you just kind of took us through the 3 levels of normalization, and we ended up with a student table, an advisor table. Can you go on to the next slide there?
And then so we end up
a
with these
registration table. Right, so the student, the faculty, and the registration. So we took that one unnormalized sort of spreadsheet-like table.
Yeah, exactly, yeah.
And you broke it up using these basic principles of normalization into 3 discrete entities of information. And just summarize that for me. So we went from one big table to 3 different ones. Why is that going to be valuable to me in my database?
Well, when we see it, so what now when we start retrieving this content, so first off, we're not going to have a bunch of, if we go back to our CDs, we're not going to have a bunch of jazz in there 100,000 times or 50 times. We're going to eliminate a lot of redundant data. So now, if I normalized an Excel spreadsheet at 1,000 rows and 80 columns and was able to normalize it in database tables, I'm going to have less data because it's going to be stored in there, because I'm not going to have jazz in there 500 times. I'm going to have jazz in there once. It's going to be a one table one time, and I'm going to reference that table. Every time I have a CD in there, I'm going to reference that table and say, yeah, jazz associates to, general ID 123, and I'll reference that. So I'm actually creating a cleaner environment, less redundant data, and all my columns that are associated or within a table, the new tables, are all relevant to each other. They're all associated with that primary column. We're going to talk about that, what that means in just a few moments. We've already introduced the term, the primary key, and we're going to actually roll that out and show you how we do that in just a few moments here. So we've kind of cleaned it up. We've got more tables, so you think, wow, I went from one table to 3, but now when I get ready to retrieve it, when you get module 4, and I want to be able to slice and dice this information, it's going to be so much easier for us to do so than what we could do in an unnormalized data table. Okay.
Thanks. Yeah, that looks really good.
Great, thanks. All right, referential integrity. So this process that we just talked about too, so let's just review a little bit on the normalization. If you're thinking about where do I start, you can use the third normal form, first, second, and third normal form, to try to look at the content that you have in your spreadsheet or in your unnormalized data table, and start with like, all right, how can I create this environment, this object modeling that we were talking about earlier, to create this environment that allows us to have this data and implement that cleaner environment by using the third normal, up to the third normal form. Referential integrity is what we use to get those tables to talk to each other. So now I've got 3 tables. Brian, it sounds like it was a lot easier to have one table because they were all in one spot. Granted, it may have been easier for that piece, but what we're going to be able to do with this content when we kind of slice and dice it, as we're going to see in a couple modules, is really blows away the idea of what we can do now with when we're in an Excel spreadsheet and we can go to the top and we can click the column header and sort of ascending versus descending. We're going to have a lot more we can do with that. So that's the good news. Referential integrity is getting those columns, those tables, to talk to each other. So this includes, or you'll see this referential integrity is RI. It's a concept to ensure that you have relationships between the tables that we just created. RI can ensure that the data is clean, and it makes sure that data that we're adding is valid data. So not only have we separated content out, we've now created an environment that's going to enforce that when I'm adding data, it's going to be valid data. And we're going to do that by introducing what are called primary keys and foreign keys. So if we go back to, I'm going to go back a couple slides here. If we go back to here, our student number is a primary key, we'll say. And what I can do is I can have it, or is a foreign key. And my bad again, my registration has a student number on it, and it also has a students over here in this table here. So we're both using 1022. So what we're going to do is we're going to reference one table to the other table. One table will have the primary key, and one table will have the foreign key. So the foreign key is used to validate the content or the value that I'm adding is a valid value. Kind of sounds a little bit redundant, but it's not. So if I'm using the students, my registration, when I go to register, it's going to look at 10022. When I enter in, if I typed in 1021, it's going to bebop over because that's a foreign key over to the students here. It's going to jump over there and say, there is no 1021. So not only does it enforce the referential integrity, it enforces that we're adding valid content by making sure a student 1022 exists or a student 1021 exists before it allows me to add content. So not are we gaining the normalization of having the ability to slice and dice, it's actually performing data integrity by ensuring that I'm adding content that's valuable. So if there was no student 1021 and I try to add content into registration, it's going to say, dude, I can't work with you because there's no student 1021. But being there is a student 1022, when they register for classes, it's going to check to see student 1022 exist in the students table. It's going to also check to see who the advisor is. And if there's information that we need about the advisor, we're going to be able to write query select statements to be able to retrieve that content. So that's the idea of primary keys and foreign keys and allowing us to be able to reference the content between tables. That's that referential integrity to get us the ability to kind of double check or cross check with the tables that are involved to make sure that the content that we're adding is valid and to make sure that we're able to retrieve this content as we move on down the road and we look at some of the select statements. Now, we'll talk more about this when we start looking at the keys, but with these keys involved, we can only have one primary key on a table. And there may be other cross checks that I want to perform to make sure they're valid. So we can also apply what's called a unique constraint or a unique key constraint. What this does for us is allows us to not only just do a cross-check on an individual column with the associated or composite key, associated primary key, but also I can do cross-checks on what are called unique. And what that does is enforce uniqueness for us. Triggers can be used to enforce referential integrity as well. They require some code. A trigger example would be every time I insert a column, it may be as simple as send an email to the advisor saying that there's a new student that's been assigned to you. So it could be that simple. When a certain action takes place, that trigger performs tasks or multiple tasks. It could be as simple as sending an email to the advisor saying student now 1057 has been assigned to you, so they receive an email saying that they have another student that may show up at their door looking for some assistance when it comes to the performing the advisor role. So that's referential integrity. Pete, anything you want to add to that?
You kind of just blew my mind again. I'm going to just back up.
I got to quit talking.
You went all the way to triggers and what happens with respect to referential integrity. When something is added to a table, you can invoke a trigger, which invokes functionality. And I'm still thinking about my CD library. I'm trying to imagine how that's going to come into play. So that's another super advanced topic. We're going to get a little bit in the next couple of modules. We're going to talk about some of the functionality you can do in a database management system where you can actually invoke some of the code, some programmatic code on an event or a trigger on a database. But I think we're going to get into a demo here in a minute where we'll be able to summarize some of this. But I think normalization, pretty complicated because I went from a whole bunch of columns in a single thing to a whole bunch of smaller pieces that have fewer columns.
Right, right.
So I kind of understand that, even though we're not going to talk about creating tables, like actually creating a table, we're going to talk about in the next module.
Right.
But now we're conceptually, I get the idea that I take this unnormalized collection of data, which is my CD library, or your original example of the inventory was a good one with a whole bunch of products and a whole bunch of metadata or columns about the product on a shelf at a grocery store, right?
Yeah,
I can see how I might break that down by brand, or I might break that down by category. Category seems to be a common thread across all of these examples, which is pretty good, right?
Yeah, definitely.
But it gives us a logical way to put things together so that they're in discrete pieces where I'm going to be able to, I think, use them in a smart way to answer different questions about my data that I have a really hard time with in this sort of unnormalized spreadsheet-like view.
Exactly.
Right. Okay.
Yeah,
good.
definitely.
Yeah, I'm tracking you.
Good recap, definitely.
Yeah. But triggers, seriously, triggers is like 300 level.
Yeah.
So let's keep it on the level.
So we'll keep it. We'll keep it. I just want to introduce the fact there are ways, there are tasks, including triggers, that can be used to enforce referential integrity. We won't get that deep in this class, but they are out there for us. All right. So methods for enforcing referential integrity. We just introduced primary key, foreign key, unique constraint, indexes. We haven't talked about yet, and triggers. Here's the idea of a composite key. So I may have a column. I may have a table that, for instance, let's say we have a table that contains driver's license. And if I go in and my driver's license for Arizona is BR549, if anybody remembers that reference to something that's an old TV show. Anyways, if my driver's license is BR549 and I live in Arizona and Pete's driver's license is also BR549, how can we make that a unique key in a table? We can't by itself, but what we can do is include another column called issuing state. So now my composite key would be BR549AZ, his would be BR549WA. So now those two together makes that data unique. Okay, so that's what a composite key. The primary key has to be unique. It may not be possible by doing it with that one column. So we may have to use multiple columns. If we use more than two columns or more, it's considered a composite key. All right, so if you see that, because sometimes you might see where it says something about having a primary key is like, well, it's got 3 columns. Well, in order to enforce uniqueness, we need 3 columns. So that's what that's alluding to when you see that composite key option here. All right, so let's go. Still staying with referential integrity. We're talking about constraints now. Here's that primary key constraint, and I just mentioned this a little bit already, kind of jumping ahead. Primary key is on 1 or more columns. It's required to provide the uniqueness in a row, in a table. That helps enforce the referential integrity. Often it'll be referred to from another table using a foreign key. But a primary key is an attribute or a set of attributes that uniquely identifies that row. So if it's a set of attributes, it's that composite primary key that we talked about. A table can only have 1 primary key on it. Not 1 column, but 1 primary key that could be a single column or multiple column. And a column that participates in this composite primary key or individual primary key cannot allow null values, which means content has to be added there. So I can't just skip by when I'm adding content. So if you're going to make a column part of a primary key constraint, then it requires content being added to that. And you can enforce that when you're creating the columns, and we'll see that a little bit later on. So the primary key is used for that. The foreign key is used to reference that content. So the foreign key is a column or a combination of columns. If the primary key uses 2 columns like we did with the license number and the state code, well, the foreign key referencing that has to use that to reference it as well. So it references it as a unique constraint that's created over there for that primary key. Unlike a primary key, a foreign key can have null values. So be careful on how those two are implemented because they're implemented slightly different. But you're going to see that a primary key is going to be accessed by the reference by a foreign key. So that's going to allow us to enforce that referential or data integrity by making sure that we have valid content when we're adding our content into our tables. So this is the diagram we saw earlier. And what I did, all we've done here is we introduced earlier on that we had the foreign key, which are the blue items, and we had the primary key, which are the red items. So now what happens is when I add a new product into the products table over here, when I type in a value for product subcategory ID, it's going to jump over to the products subcategory table and make sure that this foreign key references a primary key here. Now, inside of this table, it's like, oh, by the way, this is a subcategory. If I'm going to add when I add an item to this product subcategory, it needs to make sure there's a major category, a top category. So it's going to check this table down here. So see how there's all sorts of cross-checking that's going on as I'm adding content. When I add an item here, it's going to double check to make sure that's a valid item here. When I add an item here, it's going to make sure it's a valid item here. This product category ID here is a foreign key that references the product category ID in the product category table. So all this cross-checking is making sure that when I'm adding this content, it's all valid content that I'm adding, and these tables are tied together. The relationship is built between these tables using these keys.
Can we talk through that one more time?
Sure.
Let's go look at that slide. So we have 3 tables. So I'm going to go back to your grocery store example here for a minute.
Sure.
We've got a spreadsheet full of all the products with categories and subcategories, and it's in one thing.
Right.
And I went through the exercise of denormalizing my data, which led me to creating these 3 tables. Yeah. And then with the referential integrity concepts, there are these specific relationships that include primary keys and foreign keys in these tables that kind of manage the relationships between these tables.
Correct.
Right? So
Perfect.
let's just go, I'm going to give you one example, and I'm going to try and talk through this. You correct me if I'm wrong.
All right.
So in my grocery store, we sell strawberries.
Okay.
And so in this example, and you've got a whole bunch of columns, I'm not going to worry too much about them, but strawberry is the product. It's got some product ID, which is unique, and I can see there's a key next to it. So that's the primary key in the product table is a product ID. So we'll just say strawberry is number 1.
Okay.
Product ID 1, name is strawberry. It's got some product number that's involved in my inventory system. Its color is typically red. Those kinds of things exist about the product strawberry.
Right.
And then the product category, which is on the right side of the slide at the bottom, we're going to say that there's a product category called produce.
Nice.
Right? And the name is produce. And it will have a product category ID of, I don't know, maybe produce is 25.
Okay.
Right? So the subcategory of produce for my strawberry is going to be fruit.
Right.
Or berries or something like that, right?
Fruit sounds good, yeah.
Fruit, we'll call
I think
it fruit.
strawberry's a fruit, I don't know.
Strawberry is a fruit and
It's
a berry.
Tomato's that weird one, isn't it?
I get confused
Tomato,
about that.
I think it's a fruit, and I think it's a vegetable.
We're going down a hole I don't want to go into, yeah.
Okay, we'll
so subcategory of fruit has its own primary key for fruit, but then has a foreign key relationship to the category, which is produce.
Correct.
And then back on my product side, when I list the category, the subcategory specifically there of fruit, it's going to have a foreign key over to the primary key in the product subcategory table.
Exactly right.
So I've got this list of stuff that includes all of my products, and I started with a spreadsheet, but if I want to get it into a database, I have to denormalize it, which means I need to think about all the redundant data and how to simplify it down. And then I have to figure out how to have relationships between these tables that include primary keys and foreign keys, so that I can keep my integrity of my data all together, so that I can uniquely reference things like the category and subcategory and the product name and those kinds of things.
Yeah.
Do I have it? Is that kind of what you're talking about?
Perfect explanation.
Okay.
Definitely, yeah. So those guys make sure the data is being added is valid data. That's good. That's what we want to make sure. Again, we've taken our denormalized table, our unnormalized table. We've normalized it. It requires some additional tables. We got to get those tables to talk to each other. They need relationships, and the primary key and foreign key.
And I can start to see where we're going now, because in my spreadsheet, I have fruit listed in one column for everything that has a row that is a fruit.
Right.
So I've got strawberries and bananas, and everything just says fruit.
Right.
But I don't have any idea how many categories I have, because fruit is listed 25 times, and crackers is listed 25 times, and I don't know. But if I do it this way and I break my data up in these tables, then I can just like look at how many categories I
Yeah.
have because it's only listed one time
Right.
in the category table.
That's back to normalization where we got rid of
I've
the
eliminated that
redundant data.
redundant
Yeah,
data.
absolutely
Okay,
perfect.
I can
Really
totally
good.
see how this is going to be a lot easier for me to use.
Yeah, and we start retrieving this content in another module too. The way we can slice and dice and generate information compared to our spreadsheets is going to be phenomenal.
Well, now I'm really curious how many genres of music I have in my collection, and I want to know like how many records I have by a particular band.
Yeah, yeah.
And right now in my spreadsheet, it's really hard to get that kind of
Right.
information out.
Yeah, you can filter, you can sort it and stuff like that. You can't,
Yeah, but then I have
can't get a good
to
report.
count each row.
Exactly.
It's super
Yeah,
complicated.
definitely.
Yeah.
All right, so hopefully that helps clear up the idea of taking a table, normalizing it using a third normal form, taking the table, normalizing it, and now, okay, we've got all these tables. I got to get those tables to talk to each other. So we use primary keys and foreign keys to create relationships between those tables so they can talk to each other. And I'm able to validate content, and I'm able to see, you'll see shortly, to be able to retrieve content using table content that's stored or data that's stored in multiple tables. I'll be able to retrieve that content. So we're going to be able to go in and move that. All right. Do we want to try to do a little ad hoc
Let's do it.
library?
I think we should.
Want to
Let's
run
go.
with this?
I think we should work on my CD library
All right.
right now.
Okay. Let's do this. So I need to come out of this screen so I can go into one of these deals here.
So in this case, you're going to be my database administrator. I'm
Okay.
going to tell you about my data, and I'm going to try and guess what sort of normalized form and things
Yeah.
I need to do. But let's see if
We
we
do
can.
CDs, you said, right?
We're going to do the CD library,
Okay.
and let's see if we can create just the basic structures that we need for what I think the tables are going to become
Okay.
later on.
Okay.
And I'll talk you through, sort of like the grocery store example. But I
Right.
have this huge spreadsheet, and it's got all of the CDs that I've got, all the albums.
Okay.
Right? So I need, and it's got a whole bunch of columns in it, like artist and genre and the date that I got it, and
Right.
like, there's probably 25 because I keep track of a variety
Yeah.
of different ways that I like to sort them.
Cool.
So, but let's just start with those three. It sounds like now we're talking about I need something to manage the CDs, but I don't want the artist listed redundantly, right? Because now that I know about normalization, I want to eliminate the redundancy.
Right.
So I probably need something to track artist.
Okay, so let's add a table here. So we're going to
Let's start with the first one. Let's just start with the CD.
So add a table. I'm just going to throw square. All I do is square boxes here. Oh, let's get some
Got
fill
it.
factor on it for some reason. Let me get rid of no fill here. All right.
This is sort of the fundamentals of database design using PowerPoint.
Yeah, pretty much exactly.
Right. Which we don't
There are
necessarily
better ways
recommend.
to do this, but
Right. There are lots of tools actually that do this. In fact, Visio has some great designers for doing relationship modeling and things like that. But
So this
we're going
one's
to
gonna-
stick simple here.
yeah, we're going to just. What we're going to call this one? This first table is what?
I think we can call this CDs.
CDs. Okay.
Although nobody buys CDs anymore, right? It's
I know.
all digital, so maybe we should call it albums.
There you go. That's a good. That's
Should
a
we call it
universal
albums?
name.
Let's call it albums.
Albums. Okay, good.
That way we're modern and ready for
Yeah, now it sounds
future
cooler. Even,
media
definitely.
changes going
sounds
forward.
better that way. So now we're going to go ahead and do this. We're going to have to add another table because you said you wanted to.
Yeah, I think the question that I want to answer about my data is how many categories or how many genres
Okay.
do I have? So I think I can kind of detect that since an album has a genre, and one of the things that I want to learn is how many genres I have. I think one of the possible things that we're going to need here is a genre table.
All right. Let's see here. I can't get this guy here.
Can you actually make that bigger? Do you want to just maximize your PowerPoint window
Oh,
for
sure.
me?
Well, let me do that.
That'd be
Yes,
great.
it will.
Maybe you can
Okay.
make that slide thing smaller too, and we get these boxes a little bigger.
Gotcha. Slide that. How about that?
Now I can see it. Good, thanks.
Nice.
Yep.
Good call. Look good
Yep.
to me. It's sitting right in front of me.
Right.
Get this centered.
So that's going to be albums, and then that one's probably going to be genres.
All right, I gotta figure out here. I get this fill out of this thing here. Fill.
This is really just a chance for you to demonstrate your PowerPoint
my
prowess
lack of skills in PowerPoint.
for all posterity.
All right, so and here we're gonna add. This is gonna be.
I think you just click and type.
All right.
Just click the box to select it,
There
and
it
just start
goes.
typing. That's going to be genre. Except now I think you've got white text on a white background.
Yeah. You can't see that? Really? I can see that perfectly clear. I don't know what the
Because
problem
it
is.
was originally blue and you made it white, and now. There you go. Okay, great. So that's genre. The other one is album. And then I want one more for artist.
Oh, yeah.
Because I think it'd be really interesting to figure out how many albums I have from a particular artist.
Who's your favorite artist? Do you have a favorite? Really? So many nowadays.
You know what? I've been a drummer for as long as I can remember walking. So most of my favorite bands have really awesome drummers. The last band I saw live was the Dave Matthews Band. How's that? Is that a good
nice.
answer?
That's
and I
good.
have a whole bunch of his records in my collection, so
Okay.
that might be our example.
All right. And this is going to be artist.
And that's going to be artist. So I've got this spreadsheet. It's got all my albums in it. I've got a whole bunch of metadata, including artist and genre and the date that I acquired it. But now with normalization, I can break those things down into these tables so that I can look things up like the list of artists, the list of genres. But now we have to do the relationship between them. So
Right.
let's just type in these boxes then. I need primary key for everything,
Right.
right? So that I can give it a unique identity. So just click in the box, and what would we call the primary key for the album table? Probably like album ID.
I would say
right?
album
Does
ID
that
would
work?
be the easiest one. I don't know why it keeps defaulting to white text.
It's because we tricked you and you changed the color of the box the first time, but that's fine. Good. So that's going to be album ID. And that's my primary key for that table. Can you just maybe put in parentheses, that's primary? Yeah, that's great. So album ID is over there. And then we probably need primary keys for the other ones also, right?
Yeah.
Just
So-
put it after artist. Just hit return there.
It's let me jump back in here
There you go.
and hit there. Oh. Yeah, see this guy here doesn't like.
You need to get your insertion point on it.
There it goes.
There you go.
Artist. Okay, this PK is going to be.
Artist ID probably, right?
Sounds good.
I'm sensing a theme here. I think we're going to probably talk about some naming conventions and stuff like that in the
Yeah.
next module.
Yeah,
but
absolutely.
just conceptually here, I have a primary key there, and then I've got another one there for genre. I'm going to guess this is going to be genre ID.
That looks consistent to me. Did I spell that correctly? I don't know.
Yeah, that's right.
Okay, good.
It's good enough for the example anyway.
Yeah.
So primary keys gives us unique identity for all these things, but now I need to have a relationship between them so that I actually can do the lookup things that I want, like how many albums do I have that are in the jazz genre?
Right.
Right. So how would I make a relationship between genre and album?
So we need album ID to be able to access genre to check for that.
Album ID so I can check for genre, and conversely, I probably want a genre ID in my album table,
Correct.
right?
So I can get typed into here.
So which one do I want? That's actually a really good question. Do I want an album ID in my genre, or do I want a genre ID in my album?
You want genre ID and as a foreign key in albums. That's
Okay.
going to reference the primary key in the genre table.
Got it.
Okay.
So that becomes a foreign key in the album table.
Right.
And then we don't have to draw the lines between them like
Yeah,
you
we
showed
just
us
would
on the
talk
other
to each
slide,
other, yeah.
but the genre ID in the album table is the same genre ID. So if I have Dave Matthews Band live at the Gorge, which is complicated because it's a 3 CD album. We'll call it one album. We're not going to go there right
Yeah.
now. How many CDs are in that thing? But if I go to the Dave Matthews Band album, then it'll have a genre of rock, but it'll have a genre ID in the album table, and the genre ID will map to the genre name in the genre table,
Correct.
so that I can say, how many albums do I have that are rock? I can look up by rock, and I can find Dave Matthews. Is that roughly what's going on here?
Yeah, somebody actually add a name here. So
Oh yeah, genre name is probably a good idea.
yeah.
So we don't have to do the whole data model,
Yeah,
and
but
I
just-
think we've got a couple of examples now.
Yeah.
But tying that first example of that giant spreadsheet. We've got products, we've got categories, now we've got our CD library, we've got albums and genres and artists. And I imagine just to complete this thought, we'd have a foreign key in the album table that is the artist, so that not only can I look up my albums by genre, but I could look them up by artist.
Exactly. We'll
So
add that
suddenly
right
my
there.
complicated spreadsheet that has, however many hundred rows in it becomes broken down in a normalized relational model with the referential integrity so that I can look things up between them in a really simple way. And we're just totally foreshadowing where we're headed in modules 3 and 4, where we're going to talk about how you actually create this in a database. Look at you trying to draw the lines in PowerPoint. That's very adventurous of you.
Yeah, I know.
I
Especially
think
because
that's
I
a
can't get the
slippery
typing
slope,
to work.
right? So we're in module 3, we're going to talk about how you actually create these in a database. We're going to use SQL Server as our example.
Correct.
And then in module 4, we're finally going to get to the query fundamentals about how I can do the lookups and do really cool stuff using the T-SQL language.
Yeah, and that's cool. I think that's going to be the
use
cool
the
part
data.
where this is where it really comes together. Like you're used to being in your Excel spreadsheet. It's like I've got limited functionality. By creating this and doing this, performing this data modeling, the normalization process, creating these tables, creating the relationships between these tables. When you start looking at some of the complex select statements, not real complex, but some of the slightly advanced select statements, you're going to see the power of why you would want to do this, especially if you have lots of rows of content.
Let's go on to the summary slide, and then I think we'll wrap up and we'll get on to module 3.
So we talked about normalization. We talked about, remember, there's five forms. And we talked about 5 normal forms for that. Let me go big screen here. There we go. And first one, second one, and third one. We're worried about those the most. That's going to give you, it's going to eliminate repeating groups, eliminate redundant data, and it's going to eliminate any content that's in a table that's not relevant, has to be directly associated with that key. So we're going to do that first. We're not going to worry about the 4th and 5th normal form. Referential integrity, we talked about that. That's what ensures the data that we're adding is valid. We saw that with the cross-checking. When I add content, when I add an album ID, for instance, it goes out to make sure it's a valid album ID. Or if we go back to the student, it goes out to make sure we have a valid student or we have a valid advisor. Tools we can use for referential integrity. We showed you a quick demonstration. Ad hoc kind of worked okay. Primary key and foreign key constraints. Again, if you want uniqueness in other columns besides the primary key, you can use a unique constraint. And we'll look at indexes a little bit more down the road. And we just did a brief explanation of triggers, just so you know you have that option that's out there. This is a brief explanation of those different types of constraints that we have available or ways for us to enforce referential integrity. And we demoed primary key, foreign key. Unique constraints will probably be very popular when you're trying to enforce uniqueness and you've already used your primary key for a table. And a unique index is going to be created for you when you create a unique constraint. In fact, we'll talk a little bit about indexes, not a whole lot about that. And then we introduce the idea of triggers can be actually used for kind of introducing some code that might help with enforcing referential integrity by ensuring that someone, did you really mean to delete this particular item? So you can actually use a trigger for that as well. So what we looked at here was more conceptual. We looked at the idea of normalization. We talked about that. We looked at introducing constraints. And we attempted to draw out a diagram on how you might take your album collection, I like that better than just CD or DVDs, and use something like a database product like SQL Server or even Access to take it out of the spreadsheet and give you that extra flexibility and start introducing the idea of relational databases and tables within those databases. So we'll be back and we're going to continue on with our conversation in just a little bit. And we'll continue on and continue discussing what we're going to do and how we're going to really utilize the options of the referential integrity that we've just introduced. And we're going to get more hands-on with what we can do in the upcoming
Going to finally create
courses.
a database?
Yeah, we're going to start creating some stuff.
Fantastic.
Now that we've been kind of setting up with how we want to do it, we're going to dig in and kind of roll up our sleeves and start doing it.